Ji, Assalamu alaikum again. Is my screen visible to all of you?
Yes, sir.
Okay, right. So the first thing that you should know when you want to have an idea of the OLS method uh, is to know what we mean by the residual. So residual is just the difference between y and y hat. What is y? Y is the observed value of dependent variable y in my sample, and y hat is the is the estimated average value of y obtained from the fitted model. And then if you replace y hat by its right hand side from SRF, then you will get something like this. So the OLS method actually says that you have to, if you want to get the values for beta 1 hat and beta 2 hat, then you have to minimize a function of these residues uh, with respect to beta 1 hat and beta 2 hat. So we use the minimization process in order to get beta 1 hat and beta 2 hat. So what we do, we define what we call the sum of squares of the residuals. Summation ui hat, summation is missing in this slide. So summation ui hat square, which is given by summation of this y minus y hat square. So the least square principle says that this sum of square should be as small as possible if you want to get the corresponding values of beta 1 hat and beta 2 hat. How it is actually implemented, okay, you have to differentiate summation ui hat square, the sum of square of the residues, with respect to each of the parameters that you are trying to estimate, okay? So, and you have to take the partial derivative of this function with respect to each and equate to 0 and then solve it. Uh, Although we are not going to actually consider it step by step, but just for your consideration, I would be sending you a file which would give you a detailed explanation how this OLS method is actually implemented. So there is a PDF file that I'm going to send you in which you say if I have got a simple regression model, right? And for that, I have got the estimated regression model over here. So how I'm going to estimate beta naught hat and beta 1 hat. So you have to define the residue, and then from the residual, you have to define the sum of squares of the residual, which would look like this. Let me show you just the relevant portion of these pages. Okay, although this gives you a much more detail, uh, but you have to partially differentiate the residual sum of square. Residual sum of square is the name that we give to summation ui hat square. Okay, so summation ui hat square is actually also called the RSS, residual sum of square. You have to differentiate this with respect to beta naught hat and beta 1 hat successively and get the thing. So this whole document actually gives you a step-by-step explanation if you are interested to know how this differentiation process is actually carried out, okay? But I would just show you the ultimate outcome of this whole differentiation process. Uh, Hello? G. Uh,
मैनेजर साहब अगर आप अपना माइक म्यूट कर ले।
I think there is some
अमजद।
discussion going on.
यस सर, अमजद अगर आप अपना माइक म्यूट कर दें अमजद साहब।
Huh. That could be nice. Otherwise, we would have the background discussions going on. तो फिर पता नहीं चलेगा कि, for example, whether somebody is trying to ask something or वो. So I'll be very thankful if the mic is on mute. Thank you. Okay. Right. So what I was actually trying to say that in order to obtain the the functions for the RSS residual sum of square, what we do, we take partial derivative of this function that we call the sum of squares of residual, or RSS, residual sum of square. We differentiate it with respect to each beta 1 head and beta 2 head and equate to 0. And when you carry out that differentiation, you will get an expression like this. From the first, when you put, I think there is some disturbance going on. So uh, it is, if the mic is muted, I would be very thankful.
सर मैं उसको कॉल कर रहा हूँ सर।
जी.
अमजद साहब।
Okay. So these two equations would ultimately give you the expression for the slope as well as the, the intercept. As you can see here, beta 2 hat, beta 2 hat, which is the coefficient of x in our model, is ultimately obtained in this way, or the alternate form is this one. I don't know.
सर आप वहां से म्यूट कर ले अब सर।
Okay. Okay. Okay.
सर आप सेटिंग में जाए सर।
हाँ. Okay.
सर ये पार्टिसिपेंट पे क्लिक करें सर।
जी जी.
गैलेक्सी J3 Pro पे सर। सर ये गैलेक्सी J3 पे क्लिक करें सर।
Just a minute. Okay.
अब सही हो गया सर।
Okay. All right. Okay. Okay. That's good. Now we are a bit peaceful. Okay. Right. Okay. All right. So the keep in mind that what I'm just telling you right now, my purpose is not to require that you should particularly go for this derivation, but I mean, at least you should have the idea. Sometimes I would be introducing some theoretic details or derivations as part of my lecture, but most of the time the purpose would be just to give you the idea how these derivations are actually obtained, without particularly requiring that you should actually reproduce these derivations in, for example, your assessments or whatever. So, but as PhD students, sometimes it's very useful, if not required, that at least you should know how these results were obtained. Okay, so if, for example, I'm saying that OLS method is applied in this way, and you just use partial differentiation, and as a result of partial differentiation you use these, you get these equations and ultimately these formulae. So don't be scared when I'm just doing that thing, because my purpose is not to require that you should repeat these derivations as part of your assessment, but my purpose is that as PhD students you should be at least aware that, for example, how these derivations were actually obtained, or how these formulae were actually obtained. So what you see on the screen right now, like the expression for beta 2 hat, which initially comes out to be n times summation xi yi minus summation xi summation yi divided by n times summation xi square minus summation xi whole square. This is just the result that you get from those two equations that you saw on the previous slides like this, right? After one or two, three more steps, you will be able to show that beta 2 hat is equal to this thing, or alternatively, it is equal to this one, right? But if you use the small xi as the notation for this deviation xi minus x bar, and small yi for this deviation yi minus y bar, then you can also write down the same formula in this way. So all these three expressions that you can see on the screen right now represent exactly one and the same thing, okay? I mean, using the sample data, if you use any one of them, your numeric answer for beta 2 hat would be exactly the same. There would be absolutely no difference. This is actually what I call the function. When I say estimator is a function, so this is actually what I'm talking about. By function, I mean a formula. So beta 2 hat in this format, in any of these three formats, if you write down beta 2 hat equal to this, then I would say that this is what I call the estimator, right? But using the sample data, if you get the answer for the numerator and you also get the answer for the denominator, okay, which I will show you in a minute, then you will get a particular numeric value of beta 2 hat, and that particular numeric value of beta 2 hat would be then called the estimate, right? So this would be the difference. And similarly, you can show that beta 1 hat, the intercept, in simple form can be written as y bar, the mean of the y values, minus beta 2 hat times x bar. So it means once you get the numeric value of beta 2 hat, you can put it here. Y bar and x bar, the sample mean for y and x would come from the sample data, and you can easily get the numeric value of beta 1 hat, the intercept. But again, if you write down beta 1 hat in this form that you can see on the screen here, or alternatively in this form, because this is the functional form, so we call this thing as the estimator. But if you use the sample data and get the numeric answer using this formula, then that numeric answer would be called the estimate, okay? So beta 2 hat obtained in this form and beta 1 hat obtained in this form are then called the OLS estimators, okay? We will be using the word OLS estimators of the corresponding parameters. So beta 2 hat that you can see on the screen like this, beta 2 hat equal to this, is the OLS estimator of beta 2, and beta 1 hat equal to this is the OLS estimator of beta 1. Why we use the word OLS estimator? Because they are obtained by the method of OLS. So that's why we are using the word OLS estimator. So from this point onward, beta 1 hat and beta 2 hat would be referred to as the OLS estimators of the corresponding uh, parameters. Okay. Now, how they are actually obtained, let me just move forward a little bit further to a numeric example and show you how these things are actually obtained. I hope that numeric example is here. Okay. Now, the data that you can see on the screen right now is actually the same data that you saw in sample 1 from table 2.4, right? A sample of size 10 from table 2.1, which was considered as population. So we have the y values here, the dependent variable, and we have the x values here, okay? Hypothetical data on weekly consumption expenditure, y, and weekly family income, x, right? So using this data, which is represented by the first and second column in this table, what we need to do, uh, if we recall the basic formula, okay, of beta 1 head and beta 2 head, let me just show you where it was here. The formula for the slope beta 2 head, which was the coefficient associated with x in our formula, you can use this one, or you can use this one, or you can use any of this one, right? Depending on which one is more easier to use. For example, in the example, we have made use of this. Remember, the last two expressions are one and the same thing, because small xi represent deviation uh, from x values from its mean, and small yi means deviation of the y values from its mean. So xi minus x bar is actually representing small xi, and yi minus y bar is representing this small yi. So using this formula for, which means this one, for beta 2 head, and using this formula for the beta 1 head, the example, numeric example that I just am trying to show you quickly, is just telling you how this whole thing is computed. Although you are not required to do it manually, because you will be using stata, but I mean, initially, when you want to learn all these concepts, at least you should look at how the manual calculations are carried out, right? And then it would be easy to just use the software to get all these things. So therefore, again, my purpose is not to require that you should actually take out a calculator and do all this stuff, but my purpose is just look at this table so that you have an initial idea how all these calculations were carried out. So column number one and column number two, they are actually representing the actual data in my sample, a sample of size 10, 10 values of y corresponding to 10 values of x, okay? And the remaining columns are just the required columns that I need for various calculations. So for the time being, ignore the column 3 and column 4, uh, come directly to the column 5 and column 6, okay? Now, in order to compute column 5, which is actually small xi, which means capital Xi minus x bar, it requires the value of x bar. So first you have to calculate the mean of the x values, which means just add up all the x values, which comes out to be 1700. This is what we call summation x. And divide this summation x 1700 by n, which in this case is 10. So 1700 divided by 10, you get this number 170. So 170 is actually x bar, the mean of the x values. And similarly, you will calculate the y bar, the mean of the y values, by adding these 10 values of y. If you add up all these 10 values of y, you get summation y, which is 1110. And when you divide this summation y by n, which means divide by 10, you get this 111. So y bar is 111 and x bar is 170. So in order to get the fifth column, xi minus x bar, you have to subtract this x bar 170 from each and every value in this column x. So 80 minus 170, 100 minus 170, you get these numbers in column number 5. And similarly, when you subtract the y bar, which is 111, from each value in the y column, you get this column number 6, which is uh, yi minus y bar. So column 5, which is xi minus x bar, is small xi, and column 6, which is yi minus y bar, is small yi. When you multiply these two together, column 5 multiplied with column 6, you get this column 8, right? So multiply every value in column 5 with the corresponding value in column 6, you get the corresponding values in column 8, and the sum of this column 8, summation small xi small yi, the sum of this is the numerator that we need in the slope coefficient, summation xi yi, right? And the denominator is summation xi minus x bar square. So if you square every value in column 5, the square of the small xi values, minus 90 whole square minus 70 whole square, you get the values in column 7. And when you add up these numbers, you get the sum of the small xi square. And that is actually what we need in the denominator of beta 2 hat. So therefore, beta 2 hat is the total in column 8 divided by the total in column 7, 16,800 divided by 33,000, and you get the number as 0.5091. And because the formula for beta 1 hat, the intercept is y bar minus beta 2 hat x bar, beta 2 hat is actually obtained as 0.5091. We know y bar is 111, x bar is 170. So if you put everything over here, beta 1 hat comes out to be 24.4545. So therefore, 0.5091 is the OLS estimate of beta 2, and 24.4545 is the OLS estimate of beta 1. Naturally, if you change your sample from this to another one, like this is table 2.4, if you change it to table 2.5, then the numeric values of beta 2 hat and beta 1 hat would actually change. That's why we say that they represent variable. So once you have computed these two numbers, then your estimated regression model, which we call the SRF, will be y hat equal to 24.4545 plus 0.5091 XR. This is what we call our estimated regression line, our estimated regression model, or what we can say our SRF. And this in common research is called the estimated econometric model. Okay, this is the estimated econometric model. The rest of the discussion uh, proceeds after estimating this model. Okay, so the first thing is that you should be able to estimate the beta 1 and beta 2 in your model through beta 1 hat and beta 2 hat using the OLS method. So this is how the OLS method is actually uh, carried out. Now, what I would do right now, I would use the same data that you see on the screen right now, and I would use Stata, and I hope we can do it together. So those who have access to Stata, I would request that they should just open it up and enter the data of table 2.4. I don't know whether you have that data or not, but if that is not the case, I will just be calling the data and you can just do it accordingly. Okay, so I want to show you how these results are actually obtained using Stata. So my data would be the one that you see on the screen right now. Okay, uh, you can also, because these are just 10 values for y and 10 values for x. So if you don't have the file right now, it's not a problem because you can just write down on a piece of paper and just enter it into Stata. Okay, so uh, let me show you how this would be done. This would also give you your first practice of entering data into Stata and then saving it with some name and then ultimately fitting a regression model and econometric model. So are you ready for using Stata? Anybody can actually confirm?
Yes, sir.
Okay, okay. So don't worry if you don't have immediately access to Stata. You just look at how I'm doing it. But I mean, those who have already got access to Stata, it would be useful if they do it along with me, because this will give a first practice in using Stata uh, for entry of data. Okay, so let's do it like this. So my purpose is first to enter this data, which of course is a very small data set. In real life, in your research, you will be dealing with a much larger data set. So I would be entering 10 values of y, followed by entering 10 values for x. I'll be also giving the names y and x in my stata, and then I will be just fitting the model. So let's just do it like that. Okay. To enter the data, the first thing is to open the data editor. You see, this is the data interface. At the top, below the word statistic, you can see this button. If you put your cursor over here, you can see the name data editor, edit, right? The other one is also data editor, but it is data editor browse. So you should not click this one because you cannot just change anything over here. So if you want to enter the data, you should just press this thing, data editor, and in the bracket, edit. If I click this one, you see a blank spreadsheet will actually open, in which each column would represent a variable and each row would represent a case or a unit. So for the time being, forget about any other thing. Imagine that the first column is the one in which I'm going to enter the y values, and followed by the second column in which I'm going to enter the x values. So the y values which I have from here are 70, 65, and 90, right? So I would just do it like this: 70, 65, 90, okay? And then 95, 110, and 115. 95, 110, and 115, right? The next numbers are 120, 140, and 155. So, sorry, 120, 140, 155, and the last one I think is 150. So this is 150. Okay. You can just press enter after just entering the data, or you can just use your cursor. And you see, by default, Stata gives the name variable1, var1, which later on you can change. So just check whether the data that we have entered is exactly the same. Okay. So this is what we have done: 70, 65, 90, 95, 110, 115, 120, 140, 155, and so on. And for the X, because we have taken one family each from each income bracket, so this is comparatively easy to remember: 80, and then 100, then 120, then 140, then 160, then 180, 200, okay, sorry, 160, then 180, then 200, 220, 240, and 260. Okay. So the next thing is to give name. So if you want to give name, just click on the variable and come to this variable properties at the right hand panel, right? And in
सर
the
एक
variable,
सेकंड सर एक
sorry,
मिनट सर, ये डेटा हम एंटर कर रहे हैं ना साथ साथ,
जी,
हम आपके साथ सर वो रिपीट कर रहे हैं सर, जस्ट एक मिनट सर, कि डेटा हम एंटर करें सर.
okay, okay. So because we have just 9 minutes left, okay? Just
जी सर.
enter the data as usual. जिस तरह आप किसी भी और सॉफ्टवेयर में या एक्सेल में आप डेटा इंटर करेंगे, just enter the data accordingly. 10 values for y, 10 values for x. Once it is completed, then you have to give name to the first column, you have to give name to the second column, right? Should I proceed?
Yes sir. Enter
Okay.
कर दिया sir.
So if you want to give name to the first, so just click the title of the first column and come to the right hand side panel, which says variable properties. Okay. So variable properties, just click the name, and instead of var1, just give it the name y. You can also give it a label, right? You can also give it a label here. For example, you can say consumption expenditure, okay? Or you can just use the compute name. For the time being, I have used just a short name, right? So name means the title which will appear on the column, and label means the complete name of that title, okay? Then repeat the same exercise with the second column. Just click the second column, okay? And once it is highlighted here, right? Then change var2 by x, and sorry, and just give it a name income, okay? That's it. For the time being, as you can see, y and x are appearing at the title of above, okay? You can give any other name. I have used the word y and x. You can just write down the short name for consumption and the short name for income, and that will appear at the top. If you wish, you can also just go to file, okay, and click save as, just like when you will be saving any file. So just file, save as, okay, and give it a name. Let's say I just give it data1, and this name is totally optional. You can just give any name over here, and you can save it at any location on your desktop, okay? So for example, I just uh, save it in Cortova online folder with me, and you see now the name data1 is appearing at the top. Once you do it, just click cancel in the data editor, close at the top right, okay, so that you come back to the main window. Just forget whatever you can see on the screen, because it is just showing the process that you are doing over there, like the data entry. But the important thing is that you have now entered the data, okay? Entered the data for data analysis, the y data and the x data, and now you are perfectly ready to use data and fit a model. So what is the command for fitting a simple regression model in Stata? You can just go to statistic, linear models and related, click linear regression, and in the dependent variable box you can just give y, and in the independent variable box you can click x, okay, and
Sir आप
click
ये repeat कर ले sir. ये वाला sir.
g g.
After saving the data.
After
This
saving
data
the
save
data,
कर. Yes sir.
after saving the data, just click cancel the go out of the editor, come back to the main window, okay? Now
Okay sir.
click statistics, okay?
जी sir.
Come down to linear models and related, put your cursor on linear models and related,
जी sir.
and then click linear regression, the very first option.
Okay sir.
When you click the very first option in front of linear models and related, which is linear regression, if you click this option, a box will open, and this box is self-explanatory, as you can see, because it is asking for dependent variable and independent variables, or in this case, because we have just one variable. So independent variable के लिए आप क्या करें? Right hand राइट साइड पे ये जो एरो डाउन एरो है, just click it, right? So it will
जी
just
सर.
open the list of variables. From the list of variables, click Y. So you see Y would be coming in this box. And do the same in the independent variable box. Just click the right end arrow, and now check X from here. Okay? Check X from here and
Okay
click
sir.
OK. Okay, so you have selected Y as dependent variable and you have selected X as independent variable, and click OK. And this is what you will see on the screen. Okay.
Okay sir.
Alternately, if you want to do it very quickly without going into that click, 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 sometimes it takes a lot of time by going according to particular path. So the quick way of fitting a simple regression model in Stata is to come to the command window below. The cursor is blinking right now. So just come over here and type reg, which is the simple form of regress, right? Because I have told you that if you can remember the first three letters of the command, it would be perfectly all right. So simply type reg, and then either you can give one space, or you can just go to the variable window, top right corner of the screen, put your cursor in front of Y, this arrow would appear. Okay, so click this simple arrow, and you see the Y is coming in the command window below here, over here. And then do the same for X. Put your cursor on X. When the arrow appears, just click that arrow, and X would come in the command window. So it means type the reg command followed by the list of variables, where the first variable after reg must be the dependent variable. Click enter from your keyboard, and you see you get the same output with much lesser time as compared to the first one. And this is actually our fitted model. For the time being, just look at the results below the coefficient, below in the second portion, and look at the results below the COEF coefficient. These numbers which you can see below the coefficient, these are the values of beta 1 hat and beta 2 hat. The number in front of the underscore cons, this represents constant. This is actually the intercept. So the intercept is 24.4545, while the slope is 0.5090. And as you can see, this is exactly the same thing that you had in this particular slide, right? You see 24.4545 and 0.5091, right? So this is how you can just do it like that. I think the session is ending, so we would end our session right now. Uh, or if you wish, we can just continue. Just tell me very quickly whether we should continue or whether we should end it over here and continue next time.
Sir, it's enough for today, sir.
Okay. Okay, so we
Because there are a
have,
lot of things.
okay, so we had our first session of Stata along with the OLS method. In the next lecture, we would go for the multiple regression model and how to use Stata for that.